Well, hi, and thanks for joining me here in my shop while I go another step with this, what is becoming to be a really cool tube tester. Boy, just to think this has been sitting around, and every time I looked at it I thought it was nothing more than a supply for knobs. I never... So anyway, last thing that happened on the last video was discovering that the meter is sticky up here. Now it seems to me I checked the meter initially, and you know what, it may have been sticky then, or it may not have been initially sticky, because I seem to remember it going all the way over. I could be mistaken about that, but at this point it seems to be sticking up here because it's moving over most of its display. I'm not inclined to do something about this right away. Obviously, if this meter doesn't work, this whole thing is finished. So I really want to be careful with this. I don't want to jump in there and start doing something to it and then find out it's finished. So my guess, I think most people would guess, there's a bit of dirt down in here somewhere. Somewhere the mechanism is bumping into some dirt, something like that. And maybe with the that's why I was trying to whack the meter a little bit. I didn't really say what I was trying to do, but I was actually trying to clean off whatever was in the way. Well, whatever's happening is quite firm, so anyway, I won't worry about that. Now the next thing is the that control which I try to gain, which doesn't seem to have any effect during the special procedure with the special extra resistor, all that. Don't know. I still don't know what happened there. I'm assuming that was okay. The behavior of the machine is the behavior we were looking for, except for when I adjust the adjuster, nothing happens. So I don't know. I'm just going to leave that, move on. Next issue here, I think there was one more thing. That's right, the GM measurement for the tube that's in here, the 6C4 tube. So I have it measuring 1500 in this one, in this tester, and in my other tester, I was going to say reliable, but I don't know if it's reliable. It's more like 2000. Obviously they both can't be right, and not so obviously they both can be wrong. I mean, they could be completely wrong. It could be the actual GM of this tube is something else entirely yet. What I plan to do today is carry on as if everything is going fine and do the next step. The next step we'll take a look at it on the screen in a moment. Still fooling around with the GM side of things. I believe what you're doing in the next step is you are testing or measuring the GM of this tube, a 6C4. You're making a note of where it is. I did this in the last video. You make a note of where it is on the 3000 scale. You then advance the scale and you look at the reading, and then there are adjustments. So when you're all done, you get exactly the same reading on all three scales. But is that the right reading? I don't know. It doesn't seem to indicate in any way that you're somehow... I mean, how do you get to the right reading on this? I wonder if that's what the big resistors were doing. They're setting the machine up for a forced GM measurement. I don't know. I don't know. Let's carry on though. Like so many things in this work, the schematic, the instructions for doing the alignment, they're based on complex information about the device. But the complex information is not made available. All you get is sort of the what can we call it? Extracted information in the form of instructions for doing an alignment. So that's what you're left with. Somehow you have to see through the schematic and the instructions that you get to try to understand what the designers were intending with this. That's what I think. If you really want to get a good grip on these things, you got to think that deeply. So let's go and do a next calibration test. The steps of which I don't understand. Let's go take a look at it. Okay, here we are. So we just finished this up here, and then I performed this step here, but I did not complete it. I did not make any adjustments. So let's just go through it quick. Basically, it's test the tube. So yeah, test the tube. Get the tube ready to test. Test the tube here. Note reading on the 3000 GM scale. Note the reading. without changing anything whatsoever. Switch it to a different scale and note the reading. If the reading is not the same, if it's not whatever it was up here, if it's not the same, then you make an adjustment. Where's the adjustment? Here it is here. No, wait, I missed it. Adjust potentiometer P5A to get the same reading. And then you do the same thing on the last scale, only now you're adjusting a different adjustment, P6. Turn off the instrument. So we'll do this. So what we're going to do is going to make the instrument either, we're going to make it the same on every scale, at least at the reading point for that tube. Kind of crazy arrangement here. It seems a little crazy to me because there isn't, I don't know. Let's do what it says. Do what it says. Put this on, put this online. I think we're ready to switch on to power. There we go. I've got the dim lights in here. Everything's okay. Full power. So the line voltage test is right on the money there. Okay, check the bias. It should be 4.8. Looks just a little low. So how do I know when this meter says 4.8 it really reads 4.8? Now's my chance to whack this meter over. Yeah, it sticks right there. Okay. Hopefully I didn't burn the tube out doing that. Now, the test button's not pushed, so I have the feeling there's no current flowing through the tube. There's 4.8. Ready on the test. We're on the wrong scale. We're on the 3 scale. Guess when you flip it on to bias, it automatically adopts this 0 to 5 volt scale down here. 0 to 10, 0 to 50, depends on this. That's right, I'm just learning still. Let's take a reading and we will note the value this time. I actually have to write it down. There we go. So we're reading this on the 3000 scale here. You know what? I'm gonna put my close-up camera there. Why not? Where is it? Let's get a good look at the scale. You know, I'm gonna fix up the video here. Hang on. I can do something cool. Okay, so you can see how I've craned the camera right above the meter there, and this is what you see. That's a parallax-free view, looking straight down onto the meter. So we will put this, it's in test mode right now. So this is the actual GM test being run right now. I'm going to flip the meter to bias and then to line. Here's bias. 4.8. So you're looking at the 10 scale near the bottom of the scale thing where it says bias on the right side. There it says 10. So on that scale, 4.8. And then the line's a touch low now. The actual voltage is 122.9. We're just going to raise it up because this is supposed to be a precision test. Hey, quit going up. There. Okay, but of course it's wandering around a bit. So we'll go back to the test. Okay, that's the bias. What happened? The bias went up. Did I turn the wrong control here? Bias back down. That little bit of extra voltage. Back to the line there. Yeah. Wow. It did say you need to go back and forth on these two controls right in the instructions, and you're setting up your tube tester, getting ready. If you're getting ready for a quantitative test, you would need to do this very carefully, I would think. Now it looks like 4.6 to me. It's interesting, you can control this bias voltage directly, like read it right on the meter and set it like this, where in most tube testers the bias is hidden. You don't know what it really is. Okay, over to test. So a little above 1500. We're on the we are on the 3000 scale, so that would be basically just one above 1600. 1600 is the number. 1600. Now change scale. Whoa! Did I ever go down? Oh, it's where I had this weird meter problem yesterday too. Yeah, look at now, won't come back. I never cleaned the switch. Come back. Careful where you switch the switch here. Oh my gosh. I'm wiggling the switch a bit. Wow, okay, there's something quite bizarre about this because you know, if it's a bad switch, it'd be obvious by now. So tap in the tube tester. General wrapping going on. Maybe this switch, maybe it's this switch here. It's been these switches before. This is the meter reverse switch. Normal, and this is the bias switch. I shouldn't really, hey, what's going on there? Okay, so I think we know where we got a problem now. Wow, this is in GM mode, and I'm moving the 10 and 50 switch. Look what it's doing to the reading. Okay, well, we know where the problems are. Let me put it back. It's on 10 now. Oh my god, I got a totally different reading. Holy smokes, let's go back and look at the line. Is my meter unstick now? Okay, so the line is about right. Bias. Whoa, how did that get way down there? I did that somehow. Maybe I bumped the control? It was way down. I don't know what I'm doing. 4.8, back to test. There is 16 again. Meter working. Now why is it when I flip to a different scale, here we go, flip into the 6th scale, this is where the thing stops working, but of course it's working this time. Oh, that's because it's that button. Let's wheel that button. It is this button for sure. Yeah, no doubt about it. I gotta clean that guy. So we're supposed to see 1600 now on the 6th scale, and what we're seeing, I would say that's 1900. 1900, let's go back to the other scale because things are going so wonky here. Okay, so it's still 16. On the 3, we're going to make this, what it went up. We're going to make this, well, it went up. I kind of convinced myself that we can get along with the switch the way it is, but I have decided otherwise now. The switch is time for a blast. That's a blast, all right. Yeah, that's about 10 years worth of use there. But 10 years of wear on that switch. You see what I'm doing there? I'm holding the chassis, and then by the other hand, with nothing but this, I'm poking. Bad, 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 bad. Now, hopefully we've settled this guy down. Back to the other meter. Yeah, okay, so that's that scale. Let's go another scale. Now in this one, we should be on the 8th scale. We should be reading, it's reading even a little bit higher yet. A little over 2. There's 2 more scales, but I don't remember the instructions saying to continue any further than here. Okay, let's follow the, what's it doing way up there now? So I'm back on the 3 scale and it's gone up. Okay, back to line check. See, none of this would matter that much if I wasn't trying to make this thing work with precision. 4.8's gone down. But the line voltage is 122, it's still 122. 4.8. Back to the line. I think what makes this so sensitive, why you have to do this line adjust, is the dim light bulb that's inside the machine. The fuse bulb has a voltage drop on it that upsets the voltage that's reaching subtracts from the voltage that's reaching the machine itself. Bias was good enough. There we are. Now we're back to that reading on the 3 scale. Okay, so I'm going to touch the bias here a little bit and do sensitivity. Just a little movement. Oh, look at that. A little bit of movement makes quite a bit of difference this time. We'll bring this back. That should be 4.8 in the end. And then the line adjust, I would expect it to be, yeah, it's, you know, it moves the meter about the same amount it would if we were in line adjust mode. Now I got to go back and check these things. Line adjust. Nice shadow on it. Wait a minute. Is it a shadow or a pointer? Don't line up with the shadow. Kill that shadow. Nope. It makes it even bigger. Okay. Am I driving you nuts yet? Bias. 4.8. Good enough. Test that baby. Now it's reading 15.5 on this scale. This time we're going to adjust the next scale. 15. Don't read the shadow. Maybe I've been looking at the shadow sometimes. That's right on 1500. Beautiful. 1500 on this scale now. I'm supposed to adjust P5A. That's right here. Okay, I can get in there real easy. Just grab a little screwdriver here. P5A to make this thing say 15. Okay, that's good. Moves nicely. So we have 15 on this scale now. 15 there. Beautiful. 15, 15. Let's go for another 15 on the 8 scale. Now I got to adjust P6. 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 There it is. Potentiometer 6. I'm pretty sure that's what the P stands for. Now on the 8 scale, make it say 15. Wrong way. Make it say 15. So this means this thing is equally wrong now on all 3 scales, but there's more scales. Oh, 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 oh. Got caught on the power cord there for a moment. Scales. Let me just look myself here quickly. And wait a minute. Wait a minute. Here, you can look with me. Adjust potentiometer P6 for the same reading on 8K that was observed on the 3 and 6. Turn off the instrument. So it doesn't say to go into higher ranges and continue this process. Could be because by then you're so low on the scale, it's a false. It's false to try to adjust it when you go to a higher range yet. Turn off the instrument. The next thing we're doing is the GM screen balance and voltage adjustment. Screen balance and voltage adjustment. So remove this, so maybe it isn't reading exactly correct yet on the GM measurement. Remove the 64, rotate switch C to A, rotate switch 0 to 3, connect a DC voltmeter from the plate jack to chassis ground. With a range of, okay, we'll do that with a VTBM. Rotate the bias potentiometer to 0 and the bias light switch to 50. Turn the instrument on. Rotate the meter line, the meter switch to line. Adjust the line control for center scale. Adjust P14 for 60 volts. There's what we're doing. P14 for 60 volts on the DC meter. Adjust front panel controls for a 6L6 tube. Uh-oh. I don't have a 6L6, and even if I did, it would be a half worn out one, I'm pretty sure. So when we get to this point, I gotta put on my thinking cap. But let's get through this. Maybe this is the end for today. Adjust. Oh my gosh, this just keeps on going. Put a remove the lead to lug 14 and reconnect it to lug 13. Yeah, this is it. Okay, let's get through this. So I'll keep this on. You know what? I gotta do something here. Okay, here we are. I got the instructions up on the screen so we can see them too. Remove the 6C4. Turn off the instrument actually. Okay. Remove the 6C4. Rotate switch C to A. Switch C. Rotate switch 0 to switch O to position number 3. Switch element O, position number 3. Connect a DC voltmeter from the plate jack to chassis ground. Use at least a range of 100 volts. Okay, so I would use this guy here and his ground lead. And this is supposed to be in the plate. Leave that sitting like that. I think that's actually going to do it, just like that. So we'll be seeing it over here. 150 volt scale. The next scale down is a 60 volt scale, so that's a 50 volt scale. I can't do a 60 volt setting on a 50 volt scale, so 60 is going to be in this area. That's okay. Now maybe the level of precision I need, I'm going to actually double check it with a digital meter because I want this to be precise. And of course I just fixed up these VTVMs, so I need to somewhat continuously verify that they're accurate. So I'll have this meter handy for that purpose. Just stick it there. Just click the ground on here. You know what? I can actually hook it right up. Why don't we do that? And say, why don't I just rely on this meter? You know, I like these meters. I like to see them operate. We'll do that. There, both meters are going to be reading at the same time. Can't go wrong there, can I? Let's see, multiple tube testers, multiple voltmeters. Oh my God, I'll never ever. You know what else I've got in here? Multiple clocks. They all say it's 3 minutes after 10 this morning. So, are we set here? Yeah. What's next instruction? Rotate the bias potentiometer to 0 and the bias slide switch to 50. 0, 50. Turn the instrument on, rotate meter switch to line, and adjust the line voltage. Switch on. Let's bring on the power. Switch on. Okay, full power. Okay, that's just a warning that the voltage this meter is receiving is above 40 or something like that. 70 is a voltage there, right? You can see it there. Rotate the meter switch to the line, adjust the line scale. Yeah, it's dead on. Dead on. We're on line adjust, okay? Adjust, now adjust, whoops. Rotate meter switch to line and adjust line adjust control for center scale. Oh, on the DC meter, right. So we're not paying attention to this. Now we're going to watch this one and make this say 60 by adjusting P14. P14. Okay, P14 is going to be down under here somewhere. There it is. better to come at it from the back here. P14 is over there. Absolutely not. No, there's components in front of it from the back, so I'm going to try to get under it here and read 60. Let me do this with an insulated screwdriver there. So I'm noticing the 6X4 is glowing brightly in here, just like it did in the tube tester. Okay, I'm in. Now I'm watching the voltage. That would be the wrong way. This thing was turned to max. This control was still in its max position. You know what I think? I think this control's never been adjusted. Why would it be in its max position? Now it's in its other max position. It won't get to 60. I'm not getting to 60. What happens if that happens? Let's see if we can drive it down to 60 with a few of these adjustments, like a line adjust. I can get it down there, but by then the line, we're still on the line adjust here. You know what? Like, because the meter kind of jumps a little bit. You could call that. You could call that. You can call that 60. Still lined up pretty good. Incoming supply voltage 122 volts. How about this bias adjust here? Does that throw this thing off? Yes, it does. So, you know, they said set it to 0. It's actually, I assume that means bring it all the way as far as it'll go, not stick it right on the 0 number. If I stick it right on the 0 number, I get exactly 60. But that's with that P14 all the way to one edge. Probably indicating a resistor is off in here. That's probably what that's hinting at. This is pretty good. That's pretty darn good. After all, when this work was being done back in the day, it was being done with instruments like this one, or this guy. So, how much accuracy is there? How much accuracy is required? Ultimately, how much precision do you get out of this? Maybe in the end, it's plus or minus 10 anyway. You know, no matter how much you do. So if this says 60, what's this say? This says 60 right on the money. Hey, 2 thumbs up for my VTVM. So just need to double check it once or twice more and I'll be completely able to rely on this meter. Excellent. Next step in the instructions. Adjust front panel controls for 6L6. Well, it doesn't say turn the machine off. L6. So I'm at the point now where I've got to decide what to do about this. So I'm guessing they're picking a 6L6 for a couple reasons. One is the 6L6 is an output tube. It's a heavy current tube. So it put a little bit of heavy current stress on the machine here. It's a lot different than the 6C4. It also has a screen. The 6C4 is a triode. The 6L6 is a busier tube, got more elements in it. But I don't have one. Seems to me when I've read through it that what it's getting at is it knows a couple things about, the designer of this knew a couple things about a 6L6. I mean, there's no secrets about it. One is the filament current, obviously, and the other one is the plate current that should flow under certain circumstances, and I think this is why the test is calling for a 6L6. Let's read through it here quickly and see what it says. Repeat section 15A above except 2 and 7. So this is basically set the machine up and go through the initial stages of tube testing. Without changing any settings, turn the instrument off. So we move a wire from one spot to another. That's pretty interesting. You let it warm up, set it to test, If meter deflects from 0, adjust screwdriver potentiometer on P3. Now they've never used the term screwdriver potentiometer before. I know what they're talking about. The one I just did, P14, is a screwdriver potentiometer. You must have a screwdriver to adjust it. The other ones you can adjust with your fingers. They have little knobs on them. So it's the same kind of test as that other one that didn't do anything. Adjust P. If the adjustment of P3 cannot bring the meter to 0, reverse the leads. So another one of these, you're trying to solve an imbalance and the solution may be going in the wrong direction. So you switch things around and now your solution is going in the right direction. I think that's kind of what's happening here. Rotate shunt switch to 8, B, C, and D, B, C, and D. Return test switch to off, meter switch to test without changing any settings. Turn instrument off, remove the lead, turn the set on, warm up period 37, rotate switch to test. All I can do is just work my way through all these. I'm looking for note GM, rotate. Oh, so here we're doing the 3 higher scales now. Starting with the 8, which you note the reading. So the 8 was adjusted against the 3 already. So here you're starting with the 8 and then you're carrying it forward onto the 20 scale and the 30 scale to P8. Yeah. You've now completed calibration of the GM section of your instrument. Okay. Wow, I don't know if I can get through all this today, really, frankly, because I'm already on the clock for quite a bit of time here. 6L6. I think maybe, you know what I'm going to do? I think I'm going to stop here and ponder the situation. I've got to get all my output tubes out, make a decision. I have to think about the longer picture here of what I'm trying to do. I've got all these tube testers. I want a bunch of tubes, a bunch of tube testers, and mix the whole thing up like crazy towards the end. So I need multiple. I can't do this with one 6L6 tube. I need multiples. I'll use some other output tube that's similar. That's what I'm planning on doing. After a little more consideration, yeah, I'm going to have to go in and get my tubes selected and all that kind of stuff. So I'm going to stop here at this point. We got the 60 volts. Not exactly the best way to get it, but we're there. And that's it. That's it for today. See you tomorrow. Thanks for watching, and thanks for the comments too. See ya.